So for section 8.3, we're going to be looking at absolute value equations and inequalities. This should be, the topic absolute value should be a review from the previous, but basically this is a number's distance from 0. Which is why I'll have a lot of people sit there and say, well, absolute value, I don't know, it's just plus or minus that number. Well, what this is actually saying is what number has a distance from 0 equal to 5? Well, 5 has a distance from 0 and 5, or negative 5. So basically we split it, this x stays the same, and then we say we will get either a positive 5 or a negative 5 to give us that distance. We do a similar thing with the inequalities. We're saying what number has a distance greater than 5 from 0? Well, we split it. X is 5 and negative 5. The only difference here is a number with a distance greater than 5 would be greater than 5 or less than negative 5. Okay, so this tends to be an or. And notice on the side where the 5 becomes negative, the inequality flips. That should make sense with what we've done with inequalities in the past. When you have an opposite, then the inequality also becomes opposite. So short answer is, why do we flip it? Well, because it's wrong if we don't. But why does it? Because that's the side that becomes opposite, so that's the side that flips. We can do the same thing with x is less than 5. We split it. The x's stay the same. Have a distance less than 5, you would need to be less than 5. And you'd need to be greater than negative 5. So this tends to be ands. This is actually kind of an important point because we're going to be graphing these in a minute. But if I start with an absolute value that is greater than some number, not 100% of the time. If there's a negative in the x, this rule can change. But 99% of the time, what this is going to end up being is greater than a or less than negative a. So these tend to be or statements. Doesn't that look kind of like what we dealt with before? Well, if it's x is less than a in the absolute value of the x, then it tends to be what? Well, negative a and a, but it tends to be an and, so it tends to be greater than the negative, less than the positive, and we just keep the overlap. So these tend to be ands statements. I just messed that up. This one should be greater than. Anyway, so that's kind of a cheat sheet for how that works. I think I have that formalized a little lower. Let me see. So if I have x equals b, our solution will be x equals b or x equals negative b. If I have x is greater than b, x is greater than b, x is less than negative b, greater than a positive, less than a negative, that's an or. Greater than or equal to is the same thing. We just now have the equal to. But that still tends to be an or. Okay? If it's less than, x is less than b, x is greater than negative b, that one flips. Less than the positive, greater than the negative, tend to be ands, 99% of the time. Okay? What if there's a greater or less than or equal to? Same exact answer, just the equal to. These up here tend to be graphed outward. So we have b and we have negative b, and they're shaded outward with either the parenthesis or the bracket, depending on if there's an equal to or not. And these tend to be shaded between the negative b and the positive b, so in the middle. That's kind of the general approach. Now we're going to kick it up a notch. So let's go ahead and look at that. This is trickier. Can you solve the first one? Well, it splits. The most common mistake is people will make this 2x plus 3 and 2x minus 3. That is wrong. How do I know? Well, when I split it up here, these x's remain the same. So when I go down here, this group that is in the absolute value should stay the same. What value changes? Well, the 5. One side we get a positive 5. On the other side we get a negative 5. So now we solve these individually. 2x is equal to 2, so that x equals 1, or 2x is equal to negative 8, so that x is equal to negative 4. I'm not going to ask you to graph it, but basically it would just be the 2 points, 1 and negative 4. It would just be those two solutions. So x equals 1 or x equals a negative 4. What happens when I turn it into an inequality? Well, we already know it's going to solve the same way. So the 2x plus 3 is going to split and stay the same. We'll have less than 5, greater than negative 5. When I solve this, 2x is less than 2, so that x is less than 1. Subtracting that, 2x is greater than negative 8. Dividing, x is greater than negative 4. Is this an and or an or? Well, I can look at my notes and go, oh, it's an and. But if you're not sure, you could always go to the graph and go, look, we are going less than the 1 and greater than the negative 4. Notice they're shading towards each other. So this is an and. Less thans, you can pretty much make them ands on this. This one splits the same, 2x plus 3, 2x plus 3, greater than 5, less than negative 5. Subtracting, 2x greater than 2, so that x is greater than 1. Subtracting, 2x is less than negative 8, so that x is less than negative 4. These tend to be ors. Or if you're not sure, greater than the 1, less than negative 4. Doesn't that look like an or? So this is an or. There's your algebraic answer. There's your graph answer. Do not forget that I will also need an interval answer. This one, I would just put a minimum of negative 4 up to 1. If you would like to do negative 4 to infinity, and negative infinity to 1 with an and in the middle, I'm fine with that. I prefer the top one, nothing wrong with the bottom one. Now this one we actually have to write two separate intervals because they are two separate intervals. So what is this one? How about negative infinity to 4? 1 to infinity. But this is not done unless we put the or in the middle. So I know to keep both intervals to the left of negative 4, and to the right of positive 1. All right, let's keep going. How do I solve these? Well, step 1. This is not ready to split. A lot of you just maybe didn't do enough homework when they get to the test, and will split this. You cannot split this here. You have to isolate the absolute value. So get that by itself. Well, we got this plus 6 with it. Well, undo it. So now I have absolute value of x minus 7 is equal to 3. Some of you are like, oh, well, that was easy. Let's keep going and add the 7. You cannot do that yet. See, it's a matter of PEMDAS. We're doing inverse operations, and we have to deal with the absolute value before we can deal with what's inside there. So how do we deal with the absolute value? There's an S word for that. We split it. X minus 7 equal to 3 equal to negative 3. Solving that, we get x equals 10. Solving that, we get x equals 4. And that would be our solution. What happens when I have an absolute value equal to an absolute value? I don't really care for these, but they, I actually haven't seen these much until I started teaching college, but not a big deal. It just splits. We have A, and the second one, when it splits, we get B and negative B. So it actually doesn't operate any differently. Just make sure you go back and check your answer, because there is sometimes that you can get an extraneous solution with this because of that that B. If it was a negative B, this tends to get us in a little bit of trouble. Just check your answer on these. But the process is still the same. For instance, how do I handle this? Well, the first one splits, y plus 4. The second one splits, 2x minus 7. One side stays the same. And not 2y plus 7. That's wrong. This side becomes opposite. Meaning what? Well, really, technically, it becomes negative 2y minus 7. So it becomes what? Negative 2y plus 7. The entire group becomes opposite from what it was. I don't know why I made that an x over there. I hope you're yelling at your screen. We need one variable there. Alright, so we're going to solve this just like we have in the past, isolating the variable. 4 is equal to y minus 7. Adding the 7, y equals 11. Over here, we're going to add 2y. So we have 3y plus 4 equals 7. 3y is equal to 3, dividing so that y equals 1. Maybe. It's very rare, but there are times that you end up with an extraneous solution. So what should you do? Well, check it. Let's check if y equals 11. 11 plus 4, we get the absolute value of 15. Just plugging that 11 right here for the y. Plugging in the 11 there, we get is equal to the absolute value of 11 times 2, or 22, minus 7. The absolute value of 15 is just 15, is equal to the absolute value of 15. I think you can tell this one is going to work out. 15 equals 15. So 11 was fine. Check y equals 1. Absolute value of, what was it, y plus 4. So absolute value of 5 is equal to the absolute value of 2 times 1 is 2 minus 7. That's negative 5. A lot of people will go, oh, see, doesn't work. Well, finish it out. Absolute value of 5 is 5. The absolute value of negative 5 is 5. Both of these answers work this time. Okay? It is rare, but it can happen where you end up with an extraneous solution. So I would just encourage you that on these to check your solution. Here are some special cases. See here, if I solve it algebraically, 2n plus 3 equals negative 7. 2n plus 3 is equal to opposite, negative 7, or positive 7. When I solve this, 2n is equal to negative 10, divide so that n is equal to negative 5. Here I subtract so that 2n is equal to 4, divide so that n is equal to 2. When I check these answers, check, negative 5 times 2 is negative 10, plus 3. I get the absolute value of negative 7, which is 7. Does 7 equal negative 7? This answer doesn't work. Check n equals 2. 2 times 2 is 4. 4 plus 3. 7 is the absolute value of 7 equal to negative 7. 7 does not equal negative 7. Neither of these answers worked. This technically has no solution. How would I know that? Well, look, whatever comes out of the absolute value, and if you'd caught this earlier on, you literally get to no solution very quickly. Whatever comes out of the absolute value will always be positive. That's why we can put a positive in there and a positive comes out, put a negative in there and a positive comes out. That's why we split it. So when will the absolute value have a negative come out? It won't. Therefore, there is no solution. Well, what if it were an inequality? Well, this would just solve to 2n is less than negative 7. I'm sorry. Be the same answer, just an inequality. N is less than negative 7. Less thans tend to be ands. N is greater than positive 7. What's the problem here? Well, here's negative 7. Here's positive 7. If I go less than the negative 7, greater than the positive 7, and we have an and, I'm looking for overlap. Where's the overlap? There is no overlap, so this ends up being an empty set. Why? Well, once again, out of this comes a positive. When will a positive number be less than a negative 7? When will a positive number be less than a negative? It won't. This will become an empty set. Last but not least, what if I solve it when it's greater than? Well, I will get that n is greater than negative 7, and n is less than positive 7. These tend to be ors when they're greater than. So if I do greater than negative 7, less than positive 7, what did we shade? This is an or, so I'm not looking for the overlap. I'm looking for everything. So this would be from negative infinity to infinity, or all real numbers. Why? Why does that make sense again? Because what comes out of the absolute value always has to be positive. So when will a positive number be greater than a negative? For any value of n, you will end up with a positive number being greater than that negative. What if we have it set equal to 0? Well, 6n minus 1 equals 0. 6n minus 1 equals negative 0. That's irrelevant this time. So basically we end up with one answer. So if I add the 1, 6n equals 1 dividing the 6, n is equal to 1/6. So here you end up with one solution. Absolute value of x is greater than negative 2. How about x is greater than or equal to negative 2? X is less than or equal to negative 2. Greater thans tend to be ands. So when I shade this, we have negative 2 greater than or equal to, less than or equal to, but it's an and, so I'm looking for the overlap. Well, there is no shaded overlap, so if I erase the shading, but there is still an overlap. They share that point in the middle. They both share a point at 2. So our answer is basically just x equals negative 2. The inequality is never going to be one way or the other, but we want greater than or equal to negative 2. Well, then x be negative 2. I think that's wrong. Let me check negative 2. I'm just going to move on that. Check negative 2. Let's see if that works. Oh yeah, it will. Let me see. I might have misread this one. Let me look. Greater than's. Oh yeah, no, this is an or. Okay. That was my mistake. Sorry. This is where I go back to the beginning. Where did it go? Back to the beginning. Not to the previous section. Sorry. Back to the beginning. Sorry about that. I don't know. I'm lost here. Let me find it 1 second. Okay. Yeah, this is what I was saying. Greater thans are ors, less thans are ands. So keep using those notes. Sorry, I didn't mean to confuse you on that. Okay? So where are we at here? Since this is an or, greater than the negative, less than the positive, this ends up being all real numbers. My mistake. negative infinity to infinity, or all real numbers. If it had been an and, it would have just been the point in the middle. So if it had been less than or equal to, just would have been the point in the middle, but I don't think that would have worked either. So anyway, some special cases. Like I said, this I'm not going to be testing you on as much, but just be prepared. Looking at this, adding the 1, x plus 5, less than negative 7. Some of you will stop at this point and go, when will a positive number be less than a negative? This has no solution. If you do go to split it, and less thans tend to be ands, then you end up with x is less than a negative 12 and x is greater than positive 2. When will I have a number both less than negative 12 and, that second one's negative 2. I'm making all kinds of mistakes, sorry. That's why this should be a positive 7. So it is a positive 2. Jeez. Alright, so I subtract the 5, x is greater than positive 2. When will I have a number that is both less than negative 12 and greater than positive 2? There is no overlap. This is an empty set. Or no solution would be fine on that. Okay? How do I solve this one? Well, we move the 2, isolate the absolute value first. Absolute value of x minus 9, less than or equal to 0. If I solve this, splitting it, less than or equal to 0, greater than or equal to 0. This actually makes a difference this time. Why? Because the inequality flips, so we end up with two answers. Less thans tend to be ands. So I'm looking for an overlap. X is less than or equal to 9. This one, x is greater than or equal to 9. So I'm looking for a number that is less than or equal to 9. So here's 9, less than or equal to, and greater than or equal to 9. This is the one where it's an and, so the only overlap is the 9. So that is our solution. That's what I was thinking last time, sorry. So just x equals 9. I cannot have a number that is both less than and greater than, but since they have a both and equal to, x can equal 9. And once again, you could check it. 9 minus 9, absolute value of 0, plus 2, less than or equal to 2. 0 plus 2, less than or equal to 2. 2 is less than or equal to 2. That is our answer.